Hello everyone. So the topic of my seminar presentation is responsible data management. In this presentation, we'll discuss about what is biasness in data, what are the ways to identify that, and at what stage we can use what tools to mitigate those biasness. So let's start with what is biasness or fairness of data. So in Paris AI Summit, Prime Minister Modi said that current AI tools are not able to generate image of a person writing with the left hand, and everybody tried, and actually the tools were not able to generate uh, person writing with the left hand. So this was because the AI tools were not trained on enough image of person writing with the left hand. So this indicates that no matter how good our model is, it will perform good only when the data fed is unbiased. So how can we measure fairness? So in the paper, we have two matrices, representation rate and data coverage. Representation rate checks the ratio of any two groups, and it should be greater than a certain threshold. And data coverage checks each subgroup should have minimum certain number of data points. So does representation bias always harms? The answer is not always. So if some group is underrepresented, and all the attributes are like similar to other group, then in this case, like we do not have any problem. As we can see in this example, in the figure C, like the data is missing uh, far away from the decision boundary. So here the AI model do not have any problem. But in the figure B, the data is missing from area around like decision boundary. Here the AI model faces some problem. So what are the ways to identify representation bias? So first, let's understand what is a pattern. Pattern is the like combination of different predicates, race can be one predicate and gender can be another predicate, and combination of those predicates can be one pattern. And now let's talk about what is maximal uncovered pattern. So it is like a subtree which is like not covered but parent is covered. So that is maximal uncovered patterns. And we have like two approaches to find maximal uncovered patterns. One is top-down approach, so called pattern breaker. So if parent is uncovered, means the child is also uncovered, so we do not need to check downstream. Another is pattern combiner. So if child is covered, that means parent is also covered, so we do not need to check upstream. There are other methods also data slicing explained in the paper, where we try to slice the data into multiple slices and check which is the most problematic slice there. Now, how can we mitigate that? So we can mitigate the biasness while dealing with the data, or like before dealing with the data, or like uh, after like processing the data. So for pre-processing, we can do one thing is we can add data for the missing subgroup, but this is always not feasible because data collection is expensive. So we can use techniques like data augmentation. For in process, we'll discuss fairness aware range query and provenance based model in further slides. And for post processing, like this is wrong in many jurisdiction, because uh, after like processing we get some result, and after getting that result, if we try to alter that, then that is like kind of unfair. Now let's talk about how fairness aware inquiry works. Suppose there is a query which select employees whose salary is greater than 65,000, and it gives us one female. So we find the representation of female is less, so we alter the query to greater than 60,000, and we get two females. So this uh, this method also does the same thing. It alters the query and try to satisfy the fairness criteria. And the goal is to find the most similar query to the original query, and do that, like we have two conditions: disparity should be less than threshold, but Jacquard similarity should be highest. So what is Jacquard similarity? Jacquard similarity is like the common between the original and new query versus like union of both the queries. And to achieve this, we use jump pointers. So jump pointers is basically like if we want like two more female, then we do not need to scan like all the data. We just can say like we just keep the record of like after how many data we can get one more female. So if we want two more female, then we do two jumps and we'll directly reach to that point. And we maintain this for like both male and female in both the directions. So we get multiple queries and we select the queries which is similar to our original query. And another method is provenance based model. Suppose there is a query, we select the students whose measure is CS and GPA is greater than 3.58. But this select suppose only one female and we want like more. So we can do is like either say measure is CS or EE. So this can get give us more data, or we can do is like GPA is less than greater than 3.80. This can also give us more data. So we can have multiple options, but we will select those query who is similar to our original query and also satisfy the criteria. So for this, what we do is like remove the conditions and get all the tuples and also make annotations in a mathematical form, like what are the like variables which helped those tuples to get selected, as you can see in this example. And all those variables are stored in a table. Like we can see like for the grades, all the grades are listed, and for like subject, like it is 1 and 0, like either selected or not selected. So we'll start checking from 1 1 1 1. So this means like MA is not selected, and E is also not selected, CS is selected, and like grade is 3.80. And we keep on changing, and then we find like multiple queries, and then we select the query which is most similar to our original query and also satisfy the cardinality constant.